Hello, Ryan. Welcome to class. Hello, Tanya. Welcome to class. Hello, Ivan. Welcome to class. Hello, Gabriel. Welcome to class. Hello, McKaylee. Welcome to class. Hello, Genesis. Welcome to class. Hello, Valeria. Welcome to class. Hello, Cal. Welcome to class. All right. Welcome to class today. Oh, hello, Noelle. Welcome to class. My name is Stitch, your substitute for Mrs. Ballard today. Can everybody say good morning or hello in the chat for me, please? Say good morning or hello in the chat for me, please. There we go. I hope you're all enjoying. Hello, Liliana. Hope you're all enjoying me, Mrs. Ballard's substitute Stitch today. All right, you ready for me to make this even better? Here we go. Hello, Tina. Welcome to class. Here we go. If I sit just right, got to go a little bit like zoomed in. There we go. Now we've got it going on. There we are. Okay. Today's goal, good morning, Sean, is to get us ready for our test. When is the test, everybody? When's the test? Tell me in the chat. Good morning, Hudson. When is the test? Good morning, Daisy. It's not next Thursday. It's tomorrow. Sorry, we've got to get this done. We still have, like, I'm going to try to cram the next, I'm sorry, Todd. We have to keep moving, okay? We need to cram, like, the next 2 units. I'm going to strip them down to the bare bones, and I'm going to try to do them in, like, 2.5 weeks, okay? So hello, Andrea. So we got to get moving with the test here, because I want you guys to have review time in order for you to do the, I don't want to just teach up until the AP test and say, good luck. That's not good, right? That's not cool. So we're going to, I want us to have some review time in there, all right? So I will have some retest opportunities at some point, probably before the end of the triad. We might do them outside of class time. We'll see how it goes, all right? But we are going to definitely need to take the test tomorrow, all right? So what I need to, this is your time, okay? And you can stay on for just the 20 minutes. You can stay on for the whole period. I'm going to read what time class is supposed to get out. Class is supposed to be out at 11:40, because last period I did not tell time well, because you can tell because I sent the text message out early, right? So I need to know from you all what problem numbers from the review that you would like to go over. So you guys tell me, and then I'll put those videos up. You three were waiting for me, weren't you? All right. So, and there were a few, and I apologize for the mistakes that were there. Things happen, I'm human, and I did try to text out while I was in meetings yesterday, but by the time I was done with meetings yesterday, I was done. I wasn't touching anything. My poor children hadn't seen me all day. Even the little guys, I was up at school beforehand yesterday. 5, 6, I'm writing them down. 8, 1, 13, 14, 15, 20, and 21. Okay. Are there any others that anybody doesn't see listed that you want me to go through? I will start with that batch, and then we will go through anything else. Okay. So let's get going. I am going to ask you to help me out. It looks like I am going to go in numeric order, even though you didn't give that. There's sort of a numeric order in the chat there. Let's see. Those two are repeated. Was repeated a couple times. Okay, so I'm going to start with number 1 and then do 2, and I'm just going to go in order, numerical order, okay, as we go through. And then as we need more at the end, if we've got more time at the end, we'll do more, okay? But you all are going to help me out. For third period will be, or second period, was super excited that you asked for number 1 because this is the one I missed in their class. They wanted this one and I didn't have time to do it. Or I exited class early and pretended like I didn't have time to do it. I didn't have to, I just messed up all the time. All right, let's take a look at this one here. So can you all tell me what the integral of e to the x is? Put it in the chat. I want to hear from everybody. What's the integral of e to the x? You should know this one without looking it up. All right. Without a doubt, it's e to the x. You're right about that. Okay. Can you guys tell me, what does the number e represent? What is that number? Does anybody know? It's kind of like pi. It's a number, right? What is the e? What number is it specifically? Can you guys tell me? It is a constant. You're right about that. But does anybody know what e is? If you put the e on the calculator, what number would you get out? Okay, Jesus is on to something. Marilyn's there. All right, it's 2.718. All right. All I'm trying to get at is that that's a constant. All right. So if I thought about this and I go, if that's a constant, it's like saying x to the 0 power, or it acts like having just a 2 there. And I know when I integrate a 2, I would get 2x, right? So when I integrate the e part, I would get an ex at the end. So I get e to the x plus ex plus c. Done. Okay, so that's what number 1 looks like. All right, let's take a look at number 2. I think was the next one on the list. Okay, number 2 was a fancy way of me asking you how to do 4 different problems at once. Okay, so I'm testing you on 4 different types of integration right there. So I get the basic integration out of the way. Okay, if it was me, I would take and write out a list of my integrals. They are on, hello, Leo, they're on the left-hand column of your notes. If you look in that left-hand column, a lot of them are there, okay? If you are going to go the lazy route, let me introduce you to your textbook that we haven't cracked very much this year, all right? It's all in there, what we've been doing, all right? I just haven't used it much because we've been virtual. And honestly, if we were in the classroom, I probably wouldn't use it much either because I do most things digitally. But inside this textbook, if you open it up, okay, right there, see that page? I know you can't see the words on the page, and I know it's now getting foggy because of the virtual background. But right there, that first page is all your derivatives and all your integrals. Isn't that cool? All right, guess what? If you flip to the next page, all right, make sure you do this before the day of the test so you can see it, because there's a little bit of weirdness in some of those in there. So you might want to go in there and understand it because they put all their u primes in there for the chain rule. Okay. All right. That page right there, it's the unit circle and all the trig identities. Isn't that exciting? That's right there in your textbook. Isn't that great? Okay. And while we're virtual, you still get to use it. All right. Okay, so if you don't know your derivatives and integrals and you don't have them memorized yet, I'd have that in front of you or write them out. Okay, if you write them out, you probably won't need any of that because you'll probably have it memorized by then. All right, before I do this one, I am going to rewrite only for this first one here because I need to bring that up and make it a negative exponent. 3 cosine x. And technically, I'm supposed to put parentheses around it because the dx has to act on all the terms. All right, when I integrate, if I'm just integrating a basic integral, what do I have to do to the exponent? Can you guys tell me that in the chat, please? So what am I supposed to do to the exponent? All right, good work. We got to add 1. On this one, I'm adding 1, so I get x to the -1 divided by -1. I got a minus sign. When I integrate 1 over x, what do we get, everybody? Tell me in the chat, what do we get when we integrate 1 over x? And if you've been doing your homework, you've been keeping up with me in the notes, these shouldn't be hard. We've done them a lot of times, right? Natural log of x, good. What do I get? I missed a plus sign in here. What do I get when I integrate just the 3? What do we get when we integrate the 3? All right, I'm seeing the 3x. Good. Okay, this is the one we were getting wrong the other day, so be really careful on this one. When I integrate cosine, what do we get? Be careful. All right, good job. We got positive sine of x. Okay, what do I need to put at the end? Am I done yet? What do I need to put? You guys are awesome. You're not forgetting the plus c at the end. Good job. All right, we've taken care of 2. We need to do 4 next. Okay, so let's take a look at 4. All right, so on number 4, I need to rearrange it first. Okay, I need to do something else with it. I'm not doing a u sub yet. It looks like there's kind of an inner function, but this isn't quite set up right for a u sub. So the first thing I need to do is maybe convert to exponents. So when I see that square root, what do I get what do I have to do to get it converted to an exponent? What do I write instead? Good morning, Pearl. All right, we look like we're on the right track. So I'm going to go integral of 5x times x to the 1/2 minus x squared dx. Okay, technically this exponent on this x is a 1, but I'm going to write it as 2/2. When we are multiplying, what do I do with those 2 exponents? So what operation do I have to do there? All right, we are in fact going to add them. Nice. So we got the integral, and I haven't done any calculus yet, right? I'm just doing algebra right now. This one's not that bad. Sometimes we do a lot of algebra and then we do like 1 line of calculus, and that's the calculus problem. But the calculus part's easy. The algebra that stinks. All right, we're going to go ahead and do our add one thing. So I'm going to go 2/2. So I get 5x to the 5/2. I divide by 5/2, or what can I multiply by? Can you tell me that in the chat? What can I multiply by instead of dividing by 5/2? All right, nice work, 2/5. I'm going to squeeze it in there. All right, and then I'm going to do the same thing. I'm going to add 1, so we get x to the 3 divided by 3 plus c at the end. It looks like I can clean that up right there. So 2x to the 5/2 minus x cubed over 3 plus c. Remember, this term could be written as -1/3 x cubed. That's fine. Both are acceptable. Okay. We are going to do number 5 next. I'm going to give you a minute there, or a couple seconds there to write down what you need to write down. Okay, let's take a look at number 5. All right. What do you think I need to do on number 5? But you're just looking at that problem. What's your first instinct on that one? What's your first instinct thinking about? So here's the catch. I have some dissidents in the chat, right? We've got different opinions on what we have to do here. So and you're gonna have this on my test and the AP test. You're gonna have one that's like, bam, it's U substitution, right? And then the next one is gonna be a nice little simple basic integral that you might have to simplify a little bit first, right? And then it's gonna go on our tangent, and then they're gonna throw a derivative, and then they're gonna say, hey, what's the Riemann sum of the with 4 subintervals, right? It's gonna be all over the place. So you have to start getting to the point where you recognize what you have to do, okay? So I'm gonna go down the U sub route because I saw people saying that, and I want you to understand why we don't do that at this particular problem, okay? Because I've trained you now to look for that inner function, right? We all are looking for that. We say inner function, that's got to be a U sub, or if we're in derivative, it's got to be a chain rule. So let's go down that route. So let's say that U is equal to x squared plus 1. What would that mean that du is equal to? So if I have x squared plus 1 as the u, what would du be equal to? Help me out in the chat. I know that we're not doing this the right way right now. I just want to make sure I want you to make the realization why. Okay, so it would be the 2x dx. Thank you for everyone who put to the dx. But check out what's wrong. I only have the dx. I know I can create a number, right? So I can create the 2. I am not allowed to create a variable, so I can't recreate that. Okay, so I cannot use usub on this, at least not without a whole bunch more work. There is a way, but it's way more work than what we're going to do. Okay, so I'm going to go back to what other people said in the chat that we're going to FOIL. So if we can simplify the algebra first, sometimes that's the better route to go. Okay, sometimes we can do both a usub or a simplification, and sometimes one's better than the other, and they both work. But in this case, I would go with FOIL. Okay, so I'm going to erase all my usub stuff. All right, and we're going to FOIL first. The hard part about this is you know too much, right? If I hadn't taught you usub first, you would say FOIL it, right, immediately. Okay, but you know usub now, so you know that there's something else that we can do. All right, it's kind of like you were graded derivatives and I taught integrals, and everything goes out the window. All right, we're going to FOIL that. So x squared times x squared equals x to the 4th. X squared times 1 would be x squared, but we have 2 of those, so I get 2x squared. And then 1 times 1 would be 1. Throw a dx after it. Technically, it should have parentheses. I'm running into my other work here. All right, we're going to add 1 to the exponent. So x to the 5th divided by 5 plus 2x cubed divided by 3 plus x. What goes at the end, everybody? Tell me one more time what goes at the end. All right, good job. Plus c. Excellent work. Okay, we got 5 done. We gotta do 6. They didn't ask me for 6 last period. I don't remember doing that one. Let's see where we're at here. Okay, so I am looking for number 6. All right. So what I would do first is simplify. It looks kind of like we have an inside function or something's going on, but I see parentheses and I see something outside the parentheses. I am going to distribute. That's what my brain is going to tell me to do. So I'm going to distribute that in. So this is really the integral of cosecant. Well, cosecant times cosecant would be cosecant squared x. And then cosecant times cotangent would be cosecant x cotangent x. Yeah. Yep. Go ahead.
Because a couple people pointed it out, so I'm just gonna let you know that number 4 and 5, I think, don't go into this correctly.
It might be just the way we're typing it in. Did we try typing it like different ways with a 1/3, or doing a 1/3 out in front or a 2/3 out in front? We tried typing it different ways. Okay, I'll double check it. I don't think what we did on the screen is wrong. Okay, so I will double check it and I'll let you know, but I won't be able to do that till at least 12:30. Okay, unless we finish super early, and then I'll look, okay, and see what I typed in. Okay, so we will get there. I think I got the same thing last period. I know I did both of those last period too, and we didn't have any complaints about my answers, so I'll look. Okay. All right, we are looking at integrating these, and the good news is that I use the cosecants and the cotangents on the review, so that might mean that it's secants and tangents on the test when I do this one, right? All right, so when we integrate cosecant squared, who remembers what we get? Or who can take out their calculus book and look it up? Oh, Erica. Erica's got an answer. All right. Does anybody agree or disagree with Erica? Okay, Marilyn likes it. Rebecca's there, Angel's there. Okay, so we want to use, it's when we integrate cosecant squared, we get back to negative cotangent. And again, it's something you read it off the chart. It's going to be a memorized thing. There's no good way to do it other than that. I guess we could probably recreate it using usub somewhere, but we're not going to mess with that. All right, when I integrate cosecant cotangent, what do we get? Rebecca's on it this time. Did you know? Well, you knew it was coming, right? Okay, there we go. And that one again, when you integrate it, okay, and the answer starts with the letter C, we put the negative in front. So negative cosecant x, and then again, we put plus c at the end, and that's really all there is to that one. It's totally like, just do you understand which one, how to convert between these two things? Okay. All right. Let me look at, let's see, the next one we have on our list is 11. We're still doing pretty good on time. All right, I'm going to zoom in on that one for you. Sometimes I forget how small your screens are. I was in at school yesterday, and my screen, my desktop screen is like half the size of the screens I have at home. So they say they're putting in new screens, but we'll see. All right. What technique am I going to use on 10? Because we're doing, oh, sorry, we're not supposed to be doing 10. We're supposed to be doing 11. We're doing 11. If you need 10, I did video it last period, so it's there, so it'll be there somewhere. All right, when I'm looking at 11, there's a couple of techniques. We just have our basic, like, memorized integrals. We have U sub, and then we've got the arcs. So which one of these is that? Which category is this one going to fall into for 11? Oh, we're going to fall into the arcs. Okay. I'm going to rewrite it a little bit so it makes a little bit more sense for our arcs. I see some people suggesting some arc sign. So let's see what happens here. When I do my arcs, I typically don't like a number on top, so I bring that out as a coefficient. And then I am going to rewrite it as 8 squared plus x squared dx. This is going to be the a value, that's the u value. Some of you did it correctly identified, that's an arc sign, right? It's a pretty straightforward. The only thing that was goofy about it was the 2 in front, so 2 arc sign, and the arc sign doesn't have the 1 over a out front, only the tangent does. So again, I suggest making sure you have your formulas handy, okay, or your all your derivatives and integral list handy. We do u over a, which would be x over 8 plus c. There really isn't much other to it other than that, okay? All right, I've got 11 done. I'm going to do 13. Okay. We have a right rectangular approximation. I was not nice and did not give you a table, okay? If you aren't given a table, I personally would draw the table, okay? And on these, I don't know if you caught the text I sent out yesterday, I accidentally, when I was just doing this quickly, I just copied the problem and duplicated it, and I forgot that I had the overestimate, underestimate question on there. So for midpoint and trapezoid, it should not be an over or an under, okay? Sometimes they do ask that, but we didn't really go into that, so I'm not asking that on our test, okay? All right, so I'm setting up my nice little table. So I've got x and f of x. All right, and then I can tell what my x values are by looking at the interval. So I'm going to go out by ones from 0 to 4. So 0, 1, 2, 3, 4. If that didn't work, if I needed to add in halves or something, I would just need to make sure I have the right number of subintervals. Probably not going to make you do halves or something like that goofy on the test. All right, I'm going to count 4 subintervals. So 1, 2, 3, 4. Okay, and then I forgot I need to do it to actually calculate the y values, right? So I am plugging into here, and I'm going to get my y values out. So I put in a 0, 0 squared plus 2 would be 2. I put in a 1, 1 squared is 1 plus 2 is 3. Put in a 2, 2 squared is 4 plus 2 is 6. 3 squared is 9 plus 2 is 11. 4 squared is 16 plus 2 is 18. All right, I am going to go from the right. So I'm going to set up my, we know we're integrating from 0 to 4 of f of x dx. That's technically what the Riemann sum does for us. All right, I'm said 4 subintervals, so I set up 3 plus signs, and I'm going to come at it from the right. So the distance between 3 and 4 is 1. My height is 18. Remember that we're looking for a base and a height of a rectangle, but we're really shortcutting it with the table. Okay. My distance in between is 1. My height is 11. My distance in between is 1. My height is 6. My distance in between is 1. My height is 3. I ran out of space, so I must be done. I really don't need the times ones. So 3 plus 6 is 9, plus 11 is 20, plus 18, I believe we get 38. Okay, let's talk over under. So to decide over under, I need to understand how my function is, what's going on with my function. I notice that I have numbers that are strictly increasing. They're always going up. So they're strictly increasing. I'm going to sketch that. It looks like this, right? A strictly increasing function. I started low, I'm going high. All right, so I'm going to just try to draw right rectangles on it. So from the right, there's 1, 2, 3. So once I've got that sketch, it's really easy to tell. Can you tell me in the chat, do I have an overestimate or an underestimate with it strictly increasing right? All right, nice work. We do have an overestimate on that one. Whew. Wednesdays are rough. I still have to do 2 more classes today. All right, I can't believe it. I feel like I've done like 10 classes already. Do you guys feel like you've done like 10 classes already today? Yeah, Wednesdays are not pretty. This isn't going to look pretty in a couple weeks, I don't think. We're going to have to figure out how to do this once we go back to a 6-period day and after spring break. Rest up, sleep all of spring break, right? Because you're going to need it after when we come back from spring break, okay? Yes, we are going to have to do this every day. And there's going to be like a learning curve to how do we do this hybrid, right? Because we're going to have some of you in the classroom and some of you not in the classroom. Even though only freshmen go back the first week, so when we come back from spring break, we are starting that 6-period day again. So I will be there by myself. I have 1 freshman, so I have to be there the first week. So. No, school's mandatory after spring break, Brody. You still have to go. Did you need me to call your dad and ask him if school should be mandatory after spring break? Okay. All right. Just checking, because I can have that done. So, all right. Let's take a look at 15. All right, so this one, we're going to take the over and underestimate out of it, and we're just going to do a midpoint approximation, but I can see where this one, because of the it's the interval probably, because I did something goofy with the interval here. All right, so I'm still going to go back to a table, okay? Only I'm going to shortcut my table. I'm not going to fill in all of it, okay? But I am going to go ahead and list out all of my x values from 0 to 6. So 0, 1, 2, 3, 4, 5, 6. Let's count. It says 3 subintervals. So 1, 2, 3. When you do a midpoint, it's always going to skip over it by 1. It will always be like an odd number of digits, right, that we have in between there. Okay. So I need to just know what the y value is for the 1, the 3, and the 5. So I'm only going to make those calculations. So let's see, 1 squared is 1, 3 squared is 9, 5 squared is 25. All right, so I'm going to set up, I'm supposed to really be integrating from 0 to 6 of f of x dx. So my distance in between is 2. Oh, I should set up my 3 plus signs, right? Or my 2 plus signs. And then my height is 1, okay? My distance in between is 2. My height is 9. My distance in between is still 2. And my height is 25. I'm not sure there's a good way to do this. So 2, I could factor the 2 out if I really wanted to. 2 plus 18 plus 50. It's 20 plus 50. Is it 70? Did I get it wrong in the answers? Is that why we're asking about it? No, it's right. Okay, cool. I know, and I don't like going over 20 minutes, and I have no idea how we're going to do that. So, I'm hoping for our class, by the time we hit hybrid, that we're in review mode for AP testing. So the tenor of the class changes a little bit once we do that. So if I can't force you to do this, but if it was me, and you have earbuds or headphones, bring them with you to school. Okay. Because I'm thinking of doing like put somebody on a whiteboard and leading a breakout room, and we do breakout rooms. Okay. So that's where I'm kind of headed. We'll do a little bit of instruction and then maybe so that way you guys can get up and do something that's not completely digital, but we don't leave out the kids who are stuck at home. Okay. Or choosing to be home. Some of us aren't stuck at home. Some of us like being at home. Trust me, if it's raining out, I like listening to the rain, but I'd much rather be at home by the fire, right? Than having to be out and walking in it and getting wet. Okay, we have conquered 15. We still have to do 18, 20, and 21, and we get out at 11:40. We should be able to do that if I don't have any more stories. Okay, 18. All right. So 18. We're given this information, and I know this was one you all had to learn this one on your own. Okay, I know it was a video part of the lesson. So all this is a fancy way of getting us to see if you understand the properties of integrals. All right. So they're telling us, they gave us the information from 0 to 3 it equals 4, from 5 to 3 it equals -2, from 0 to 7 it equals 12. Right. So I am going to look at, see this first one, it says I need to go from 0 to 5. So I know that I can break that up into 0 to 3 and 3 to 5. So I am integrating from 0 to 3 of f of x dx plus from 3 to 5 of f of x dx. Well, they told me very explicitly what I am allowed to substitute in for those two things. So this one, I'm allowed to put in a 4, and this one I put in a -2. I add it up, I get 2. Okay, so not super hard integration with algebra. It's just, do you understand what this property is numerically? All right, let's look at part B here. What do, other than the fact that I missed typing the dx. Okay, so let's pretend the dx is there. Okay, I messed up. What do we not like about it? What's wrong to our eyes? They showed it differently on Delta Math. I'm sorry. All right, we don't like the 3, the lower value is greater. Okay, so if my lower value, my lower bound, that 5, if that's bigger than the 3, how do I fix that? What's the property that allows me to fix that and make it look right? If I'm gonna, because we have to, we know we have to flip it, right? So what else do I have to do to it when I make that flip? Let me see what else I have. Okay. All right, I'm seeing some negatives on the outside. That's good. Okay, so we're gonna put that negative on the outside. Then I'm gonna go back to what we had here. I'm gonna find it, and I know I get to substitute that in for just this p, meaning I need to make sure I drop the negative down. I put in the -2, my answer's 2. It's a coincidence that both of the answers came out 2. All right. Part C is, it doesn't matter what I have there. I could have 5s. I could write it like this, right? Smiley face to smiley face. It doesn't matter. As long as those match, what does the answer always have to be? Yeah, it's got to be 0. What's going on is when I integrate that, let's say I integrate it and I get f of x, right? When I integrate from 5 to 5, and then I put those in there, well, that's going to cancel, isn't it? It's going to be 0. So it's always, always, always 0. Okay, the next one is trickier, from 3 to 7. So let me show you visually how to interpret that. Okay. So I know that I have this information that if I go from 0 to 7, It's 12 long. Okay. If I go from 0 to 3, that's 4 long. What they want me to get is what is it from 3 to 7? What mathematical operation am I going to have to do? Add, subtract, multiply, or divide? What do you guys think? I'm going to guess if you got one wrong, it was this one, right? This was the trickiest one out of all of them. It's a subtract, right? Hopefully the picture helps, all right? If you need to, you could draw the picture for all of them, couldn't you? All right, so all I'm going to do is subtract. So calculus-wise, the way we would write that would be the integral from 0 to 7 of f of x dx minus the integral from 0 to 3 of f of x dx. And then we know that it was 12 minus, I think it was 4, right? Gives us 8. If you want to stay on, you are completely welcome to do that. But if you're done, I understand. If you need a break, okay, before you have to do this again for another 45 minutes before lunch, okay? But if you stay, like I said, either way, whatever support you need, I'm there. Doesn't bother me either way. Okay, this one here, I think I just didn't get it numbered. That one was 19. So this one here is the 20. Okay. And this one is 21. Okay. All right, let's take a look at 20 because you guys asked about that one. And notice I left it multiple choice. I did that on purpose because whatchamacallit, College Board will ask this question almost in this exact same way. Okay. So they like to say, hey, do you understand what we do with U substitution with a definite integral? All right. And I kind of like it better almost because then I don't have to plug in all the numbers at the end and make an arithmetic mistake, right? I know I have the ability to do that, but I can show them I understand the concept by doing this. Okay. Can you guys tell me what would U be in this case? What's my U? I'm waiting. I want to see if everybody understands what the U is, because we still got a lot of people in the room. I need more than 5 people in the chat. There we go. Make sure we're still awake. Okay. So U equals x squared minus 3. All right. So can you tell me what does du equal then? I'm very much appreciating the people that are all putting the dx. Nice work. So 2x dx. All right. So I'm gonna do my underlining thing, right? There's the x dx. Ooh, I'm missing something. What am I missing for the du? So what do I have to put in there? What's missing? All right, we got to put the 2 back in. So I've got to put a 2 here, and I'm going to put a 1/2 on the outside. All right, let's get the U sub piece going. So I have a 1/2, and check it out. We look like we're on the right track. They all have 1/2. All right, and then we know we're going to do square root. It looks like I sub in my U. For the blue part, the 2x dx, I get to sub in du. So here comes the catch. Okay. I have to change my limits. All right. So I can't just keep it 12 and 39, but they did, right? They know that somebody's going to not switch their limits. So that one's the wrong answer. All right. So what I do is I substitute these limits in over here into the U. So I have to put both of those in. Okay. So I'm just going to solve. So U equals 12 squared minus 3. 12 squared is 144. Minus 3 equals 141. Did that get us? Oh, there, we don't even have to finish, right? It should be this one. We will, just to double check. 39 squared minus 3. Let's see. 39 squared, 1521 minus 3. Would that be 1518? I just used my answers to figure that out. So hopefully it's right. So 1518. Okay. All right, that took care of 20. We still need to do 21. Okay, so here's what I'm going to ask. I can do 21 right now. Okay. I did video 21 during last period, and I'll be putting that up. So do you want me to keep going and do 21? Or do we want to do a joke and take a break before our next class? You tell me what you want. Keep going. Okay, I'll keep going. If you still need it, I will be in the intervention room after school. Okay, we all want 21. You just love it so much that you don't want to leave. Is that what it is? Okay, or you're enjoying Mrs. Ballard's stitch today? Okay, all right. So, what shapes are we seeing in that right there? What shapes do we see? I'm going to zoom out a little bit because we've got to integrate all the way from -6 to 6. So what shapes do you all see? And I know it's a little distorted. It looks a little bit weird. I didn't get my scaling on there very good when I was trying to make the picture, and I was going fast and I was frustrated. I wasn't going to mess with it. Okay, so I'm seeing a lot of triangles and I'm seeing some half circles. Even though this half circle seems distorted, if you counted the radius everywhere, you should notice it doesn't matter what the picture looks like, it's still a circle, okay? And we would never say oval because it would be an ellipse, even though we've never gone into conics and taught that, okay? But it is a circle in this case because the radius matches. All right, so let's go ahead and we set up for our proper notation would say this, right? And then I'm going to do my geometry formulas. So my first triangle here, I know if it's a triangle, I divide by 2. Base of 2, height of 1, 2, 3, 4. Okay. Half circle means I'm going to have to divide it by 2. I'm going to do this in purple. So my radius is 2, so pi r squared. And then this guy right here is a triangle, and so I divide by 2. 1, 2, 3, 4, 5, 6. And then the height is 1, 2, 3. Okay, we're going to do some nice canceling. So these go away. I get 4. 2 cancels with one of those, so I get 2 pi. 2 goes into 6 3 times, so I get 9. We get 13 plus 2 pi. All right, so anybody else's head hurt? No, Angel's good. You want to take the test now, Angel? No, you want to wait till tomorrow? Okay. That's a good thing because I haven't put it together yet. Brody's head hurts. My head hurts. But I've been in a meeting since like 7:50 this morning, so. Since I messed up on the time last period, I at least got to go up and use the restroom. That was nice. Okay, let's do our joke of the day because I think we all need it, right? Andy has a nice St. Patrick's Day joke for us. In case you didn't notice, remember you were supposed to wear green today, right? Because it's St. Patrick's Day. All right, here we go. Come over here. There we go. Okay, Andy, what you got?
Hello, everybody. It is St. Patrick's Day. Now it's time for our St. Patrick's Day joke of the day. Why do leprechauns hate running? They'd rather jig than jog. And I'll be here all week because I live here.
All right. Okay, guys, come in ready for the test tomorrow. Okay, if you have a few last minute questions, I'll open the intervention after school. I think we've done most of it. Okay, so have a good day. Take a few minute break before you have to go to your next class. Okay, get up, move around. You're watching Luck of the Ice. That's on the Disney. It's a Disney Channel movie, right? Erica, have you heard of The Little Man of Disneyland? Have you seen that? It's a cute little book. I think I might pull it out and video reading it, and I'll put it up for you guys. There was a little man at Disneyland that used to live there before they built it, and his house is still there at the park. So I'll have to dig it out. I got to see if I can find it. Maybe during lunch.
Does the intervention start right after 6th period?
Yeah, I think I have it on from like 2:30, 2:35 to like I can go to like 3:15, 3:30 if I need to.
Oh, okay. All right.
Okay.
Thank you. You have a nice day.
You too, kiddo. See you later.